I saw this question on YouTube, and I have my way of doing it. Three methods. Now here's the method one. I start with the substitution. Let theta be arctangent 1 of x. Therefore, 1 of x is equal to tangent theta, and x is equal to cotangent theta. So my integral becomes, this is simply theta square, right? This is d cotangent theta. When x equal to 0, theta is half pi. When theta equal to infinity, 0. It doesn't look nice, so I switch them and become negative. Theta square and d cotangent theta. Good, it looks better. Then it's ready for by parts. This is u, this is dv. So this is u, this is v from 0 to half pi, and minus become plus, 0 to half pi, v du. This is v, du is 2 theta, d theta, isn't it? Now this has a little problem. Well, this is theta square. This is a cosine over sine. When theta is half pi, no problem. This is 0. This is 1. Everything's 0. When theta is 0, this is 0. This is a 1. This is when theta is 0. This is 0. This is also 0. So, but this limit is equal to 1, right? When theta over sine theta is approaching to 1, when theta goes to 0. This goes to 1, this goes to 0. So everything's 0. And plus 2 integral cotangent theta d theta is a d log sine theta, isn't it? So we can do by parts again. This is u, this is v, from 0 to half pi, minus v du. V is this, log sine theta. Du is d theta. Okay. Now this one has a problem again. Well, when theta is half pi, no problem. This is 0. When theta is 0, this is infinity. This is 0. So we have to do something over this, right? To create the condition for L'Hopital's rule. So when theta goes to 0, this is 1 over theta square, the derivative. This one is a cosine over sine, the derivative of this. And this one goes to theta times cosine theta over sine theta. When theta goes to 0, so this one's go to 1, this goes to 1, this goes to 0. So everything's 0. And minus 2 integral 0 to log sine theta d theta. Well, I have a video doing this integral log sine x dx is equal to negative half pi log 2. Well, if you want to see the detail, just go see my video. The linkage is below. So I don't repeat it here again. I simply use the result. This is equal to negative 2 times this log 2. Yeah. So the answer is equal to pi log 2. So that is the answer for my integral by method 1. Okay. If you want to see the detail for this particular integral, the linkage is below, so you're welcome to see it. Now, that's the second method. Second method, well, I have a triangle here. Now, if this angle is called arctangent 1 of x, which means this is 1, this is x. So this angle is arctangent 1 of x. For the same triangle, that angle will be arctangent x over 1. So in other words, these two angles, the sum is half pi. So in other words, I can write this one into half pi minus arctangent x, okay, square dx. Yeah. Now then, my substitution is that let theta be arctangent x. X will be tangent theta. See, it looks better. So this one is equal to integral half pi minus theta, isn't it? Square and d tangent theta. Well, when x equal to 0, this equal to 0. When x equal to half infinity, that is equal to half pi. Yeah, this is ready for by parts again. This is this dv, right? And this is uv half minus theta square tangent theta from 0 to half pi minus v du. V is this, right? Du is this. Du is equal to 2 half pi minus theta times negative 1, right? Negative 1. I changed this one to positive. So this is tangent theta d theta. Okay. From 0 to half pi. This one has a problem again. Well, this is a half pi minus theta times half pi minus theta. Tangent theta is a cotangent half theta, half pi minus theta. Tangent theta is a cotangent half pi minus theta. So this becomes cosine half pi minus theta over sine half pi minus theta. Okay, that is a cotangent half pi minus theta, which is equal to tangent theta. Now, when theta is approaching to half pi, this is 0. This is also 0. So this becomes 1. This is 1. This is 0. So the whole thing is 0. Well, when theta is 0, it's easy. This is 0. Everything is 0. So this term is 0. And plus 2. And that one, I want to create condition for by parts. This is half pi minus theta. Tangent theta d theta is d log secant theta, isn't it? Yeah. For writing this way, I can use by parts. So this is equal to 2 half pi minus theta times log secant theta, 0 to half pi. And minus through here, VDU. This one times this derivative. This derivative is a negative d theta. Therefore, change to plus, right? So log secant d theta. Yeah, negative is gone. It's half pi. Now, problems here again. For this one, secant theta is equal to cosecant half pi minus theta, isn't it? So this is a half pi minus theta. This is a log cosecant half pi minus theta. This one is equal to log negative log sine half pi minus theta, isn't it? Yeah, this one is 1 over half pi minus theta. So all doing this because I want to create condition for L'Hopital's rule. Now, when theta is approaching to half pi, this is approaching to 0. Log 0 infinity. This is also infinity. Now I can use the L'Hopital's rule, right? So L'Hopital's rule, this becomes 1 half pi minus theta square. This, the derivative would be sine half pi minus theta, and the cosine half pi minus theta, and times negative 1, right? Yeah. Okay. Now this one is equal to what? This is a cosine half pi minus theta over sine half pi minus theta. This is square, becomes a half pi minus theta times half pi minus theta. When theta is approaching to half pi, so this is approaching to 0. This is approaching to 0. So this approaches to 1. This approaches to 1. This approaches to 0. So everything's 0. Okay? So everything's 0. When it's 0 is easy, that's a 0. So now the integral becomes a log secant is equal to negative cosine, right? So I change this one to negative log cosine. Yeah. Now also we have a formula for this. A to b f of x dx is equal to, from a to b, f of a plus b minus x dx. If you know this formula, very good. If you don't, if you haven't seen it, you can prove it very easily by substitution. They are equal. So I'm using this property. This one equal to negative log cosine this plus this half pi minus theta d theta. So this one equal to 2 half pi natural log sine theta d theta. Then use this in my other videos. This is equal to minus 1/2 theta log 2. So the result is equal to pi log 2. Well, same result by method 2. Okay. Now, method 3. 0 to infinity arctangent 1 over x squared dx. Okay, method 3. First, as in my second method, which means this one is equal to 0 to infinity half pi minus arctangent x squared dx. Okay, so I can start with the assumption, let theta be arctangent x, and x equal to tangent theta, isn't it? Yeah. So this one is equal to half pi minus theta square. Dx will be secant square theta d theta. Right? Then x is equal to 0 is 0. X equal to infinity, half pi. Okay, good. Then I'm using this property. So this integral becomes 0 to half pi. This will be half pi minus half pi minus theta square. This will be secant square half pi minus theta d theta. Okay, using this property. And then this is equal to 0 to half pi. Cancel out as a theta square. This becomes what? This becomes cosecant, right? Cosecant square theta d theta. Yeah. Then I want to create a condition for by parts. So this one is equal to 0 to half pi theta square. This is d cotangent theta negative, right? This is equal to that. Now then I can use by parts. This is square cotangent theta 0 to half and plus 0 to half pi. This times this, right? This is 2 theta cotangent theta d theta. Yeah. This has some problem again. This is theta times theta. This is a cotangent is a cosine over sine. Now when theta is half pi, no problem, that's 0. When theta equal to 0, then this approaches to 1. This is approaching to 1. This is approaching to 0. So everything is 0. Okay. And this is plus 2 half pi. And here I want to create condition for by parts. This is d log sine. Yeah. D log sine is equal to tangent theta d theta. So this one is equal to by parts again 2 theta log sine theta from 0 to half pi minus 2 integral. This is a log sine x sine theta d theta. Okay, again, this is a log sine. When theta is half pi, no problem, it's 0. When theta equals 0, this is infinity, this is 0. So I created the condition for L'Hopital's rule. Now then you take a derivative, which is cosine over sine. Right? This is a negative 1 over 6 square. So this puts you to theta times theta, cosine theta over sine. When theta approaches 0, this approaches to 1. This approaches 1. This is 0. So everything is 0 again. So this one is going minus 2 log sine theta. Okay, then I use the result. Is a negative half pi log 2. So whole thing's pi log 2. Okay, from here to there, just go see my other video, and the link is just below. Okay, so I get the same result by 3 methods. Very good. So these are very good exercise for practicing the basic techniques of integrations. Okay, thank you for your watching.